Okay, power of a product property. This is the last property of section 7.3. Now this property states that a product raised to a power equals the product of each factor raised to that power. So the product, the answer to a multiplication problem, raised to a power, so I see exponent here, sorry, bad writing, equals the product, multiplication of each factor, so each one of those base numbers, oops, base, not based, base numbers raised to that power, so raised to that exponent again. So looking at this, we have two factors, and they're multiplied together, and so this product, this property means a product raised to a power is equal to the product of each factor raised to that power. So we have 3 times x, so those are our two factors, and they are both being raised to that 3 exponent. And so this is equal to us saying 3 to the third power times x to the third power. These are equivalent. So this is essentially, I like to think of this as the distributive property on steroids. Per T on steroids. So essentially, we essentially are dealing with the exponents being distributed in instead of like saying just a basic 3 distributing in or something like that. So all of this, we can say this is all equal to 3 times 3 times 3, and we don't necessarily want to make the x to the 3 turn into anything but the x to the third because we don't know what x is. But 3 times 3 times 3, that equals 27 times x to the third. So that would be our final answer. Now let's try a couple of practice problems. So here is our first one. We have negative 5 t squared squared. So all of this, the negative 5t squared, is all being squared. So essentially we can say, okay, this negative 2 is going to multiply the negative 5, or the 2 is going to multiply the negative 5, and it's also going to multiply that t squared. So we can rewrite this as saying negative 5, and because this negative 5 was in parentheses, we're also going to say, or keep it in parentheses, and we're going to, I'm going to do this in orange so we can see it. We're going to square that, and we have t squared, and it's going to be squared as well. So negative 5 squared, we can do that math. That ends up being positive 25, so negative 5 times negative 5 equals positive 25. And this next one, t squared raised to a second power, that is essentially t squared times 2. So all of this written out, we could say 25 t to the fourth. So that would be our final answer. Oh, this next problem doesn't actually have everything in it. Let's actually say it's being raised to the fourth power. So 4 times p to the third power, all of that quantity is then raised to the fourth power. So we're going to use that distributive property, and we're going to distribute it into both. So we're going to distribute that into both the 4, and we're going to say 4 to the fourth power, and p to the third power raised to the fourth. So 4 to the fourth power, let's do that math. 4 times 4 times 4 times 4. Essentially, so 4 times 4 is 16, and times 16, so 16 times 16, I'd have to think about it. I think it ends up being 216. Let's do 16 times 16. 6 times 6 is 36, and then we got 9, 0, 6, 1. Oops, I was wrong. And then 256, not 216, 256. I'm so glad I checked that math. So we have 256, and then p to the third times 4. So we're using that power of a power property right there. So we can multiply those two powers. So we end up getting an answer of 256 p to the 12th. For our final answer for this one, I'm going to do final answer in purple that time. Last one, here we go. This one's nice and tricky, and I showed this one in class. However, if you weren't in class or if you were confused, let's understand it. So we have x squared y to the third. That whole quantity is raised to the fourth power, and it's being multiplied by x squared y to the fourth, and all of that is being multiplied by a negative fourth power. So we can do this one of two ways, and I'm going to do this one way, and then I'll show you the other way as well. So we can multiply this fourth power through, so we end up with x squared raised to the fourth, so essentially we're multiplying those two powers, y to the third times 4, also being multiplied, times, here's the negative, we have x squared, whoops, should do that in orange, x squared times a negative 4, and then y to the fourth times a negative 4. So we can do all this math. We end up getting x to the 8th times y to the 12th, whatever, times x to the negative 8th, y to the negative 16. And now we can do that product property. So we can add these two things together. We have x to the 8th minus 8, and then y to the 12th minus 16. So we end up with x to the 0 power, y to the negative 4th power, culminating in 1 over y to the 4th. So that's one way we can solve it. Another way we can solve this same problem, so I'm going to move this over just a little bit, is this. So we can put all of this information in the denominator. So we could have x squared y to the third raised to the 4th power over x squared y to the 4th raised to the 4th power. And from there we can do the same steps as we did over here, except we're not going to have our negative exponents, mainly because we got rid of that negative exponent with this first move right here. Either way, it's all going to equal 1 over y to the 4th. Okay, so that's another way you can solve that problem. Hope this helps.